All right, pozdrav iz Srbije. Welcome to another episode of NT Podcast, Science and Theology, where we dive into deep questions about science and philosophy, biology, and all other stuff. So, today we have an exciting guest, Dr. Timothy Standish, a distinguished biologist and creationist. Dr. Standish, welcome. How are you?
I'm very well, thank you. It's a delight to be with you.
Well, you're let me read just you have a BS and MS from Andrews University in zoology and biology, and PhD from
Mhm.
environmental biology and public policy from George Mason University. So, how you blend this your belief in Bible creation and biology? Is that even possible?
Well, yes, in fact, it's absolutely essential. Look, um, people have all kinds of models out there for the way in which science and faith work together. But I grew up in Asia, and where I lived, there were believers in Hinduism, Buddhism, very few Christians, and Islam. And uh, at the end of the day, what I've come to realize is that to do science is an act of faith. So, take for example, and I want to be very um, clear here. I have friends who are Hindus. I love them. We are good, genuine friends. I respect them. I'm not interested in making fun or knocking the beliefs of anybody else. Having said that, one of the central tenets of Hinduism is that what we take in through our senses is an illusion. It is not real. Okay? The ultimate reality is consciousness um, in some way. It's something. It is the ultimate reality is not external to ourselves; it's internal. And as a consequence of that, think about doing science. Um, uh, Science is based on the idea that the ultimate truth can be discovered through what is observed. If what is observed is an illusion, obviously science is nonsense. That's not the direction in which you really want to go. So there are certain metaphysical foundation points that are essential if you want to do science. They are not things that can be tested using science. They're external to science. We take them by faith. They're things like what we take in through our senses is a reasonable representation of reality. We assume that we have minds that can make sense of those data that we observe. We assume that there is a rationality to reality that is out there to be discovered. At least those three things. You see other people, will sometimes add a couple more things to that list. But those are metaphysical. They're outside the realm of science, and we take them absolutely by faith. And they also happen to be things that are very consistent with the biblical worldview. The Bible constantly encourages people to believe what they see. It's one of the reasons why I enjoy reading people like the Apostle John. He's constantly presenting empirical evidence that people have observed and inviting you to draw a reasonable conclusion from that. So Christianity also, the idea of one God. If you've ever wondered, why is it that the Greeks, who are so brilliant, didn't come up with modern science? They were so close, Aristotle, we even sometimes call him the father of science or the father of biology. Um, uh, and yet it's like science was kind of stillborn with the Greeks. It didn't sort of just take off in this amazing way um, that we see it doing later on in Western Europe during um, the time that we call the Enlightenment and so on. There, where people are suddenly, we're watching this incredible expansion in scientific knowledge up until this day. Um, I suspect that one of the reasons with the Greeks was because their polytheistic beliefs. You read Homer, and all of a sudden you realize, whoa, if there are half a dozen or a dozen gods or more out there, and one's affecting the rain, and one's affecting the waves, and one's affecting this, and one's affecting that, and they have their own reasons. It's completely irrational. If you want to understand reality, then you must somehow or other, um, you know, figure out what the gods are doing, not what the laws of nature or physics or what have you are. So Christianity, there is a reason why there has been this association between Christianity and science, and why we see that most of the great, what we call founders of modern science were pretty sincere Christians. People like Galileo, Sir Isaac Newton, Boyle in chemistry, and so these guys were quite explicit in their Christian belief, and that kind of foundation is necessary for doing science. So you can call yourself an atheist or whatever, but you'll find that you're using those assumptions no matter what.
All right, thank you so much. And let me just call our audience before we start. If you are eager, as we are, to uncover new insights, make sure to subscribe to the channel and hit that notification bell so you don't miss the future episodes. Your support helps us continue to bring in experts and deliver quality content, so please consider donating to keep our discussions going strong. Now, let's get started. You have many publications, research projects, and books. And how Bible helps you in your scientific research?
Well, I think that already I've mentioned, that philosophical, that metaphysical foundation is provided by the Bible. Um, uh, that's an inescapable thing. It's these things must be embraced by everybody who wants to do science. It doesn't matter what your private religious beliefs may be. If you want to do science, you've got to believe what you're taking through your senses. You've got to believe that your brain can make sense of it. You've got to believe that there is an ultimate sense to be made of reality. And those are all things that strongly come from the Bible. In addition to that, it's very important to understand that there are different flavors of science, and so you have what people commonly call experimental science. That's the idea that you can take hydrogen and oxygen and put them together with a spark and you're going to get water and a big bang. When you do that, I remember the joy of discovering that when I was in high school and making lots and lots and lots of explosions. It drove our principal mad. He was rushing around after all of these explosions going on in various buildings. No one was ever hurt, but he was very concerned that something bad was happening and he just couldn't figure out what it was. Anyway, you know, that will work the same today, it'll work the same tomorrow, it'll work the same on the moon, it'll work, the same wherever you are. It doesn't matter. Experimental science is repeatable, and that gives at least me a high degree of confidence in the outcome, or the what we learn through experimental science. Not 100%, because sometimes data maybe can get interpreted in different ways, and theories do get modified. Certainly in molecular biology, I've personally been astonished at what I learned and believed, what's changed over the course of my career. So, for example, I tell my students when I teach molecular genetics, I start out by asking, what is it? What is a gene? And they will start giving me definitions of genes, and they're all perfectly good definitions, obviously. But what I tell them is basically, you know what? If you think you can define a gene by the end of this course, you're probably going to fail it. The reality is, yeah, 20 years ago, we knew exactly what a gene was. And we were figuring out all sorts of additional information about genes. That's really fallen apart in the last decade or so. Genes are far more subtle and complex things. There's an element of algorithm to them. They're like little logic functions. They're not just a simple little recipe for something, for a polypeptide. That's just, they're not that. I mean, that's there, but the realization that probably most genes in the human body produce more than one protein. It's very, it was very surprising for me to find that out, because I was raised on Beadle and Tatum's one gene, one enzyme hypothesis, for which they got a Nobel Prize. So this is not. So what I'm saying is that was experimental science, but it still developed in interesting and certainly unexpected ways for me, and I think pretty much everybody else who wants to be honest about it. On the other hand, you do have historical science. And the thing with historical science is that the phenomena that you're trying to explain are not repeatable. And by that, I mean, all right, let's say I want to explain how the pyramids were built. Well, I can go to Egypt, as I've done, and I can look at those pyramids, and I can measure stones, and I can contemplate all sorts of things about the pyramids. I can then come up with theories about how those stones were piled up and how they got their measurements as precisely as they did, and all sorts of stuff. But I cannot go back and see how they actually did it. And you know what? I might be right, I might be wrong with my theories. I can show ways in which you might build a pyramid, but I can't show the way that those pyramids were built, just a way that a pyramid could have been built back then. So, without time travel or whatever, what we're restricted to with historical stuff is what we can observe in the present, the ability of our minds to come up with models on the basis of what we can observe in the present, and most crucially, historical records. What witnesses at the time recorded. And we generally believe that, the closer the witness is to the event, the more accurate their ability to record whatever an event or a phenomenon is. And this is an area where the Bible becomes extremely useful. I didn't live, 3,000 or so years ago. Moses did. And so he is much closer in time to the events that he records. And so, it's you kind of have to be careful about these things because people can lie. Yeah. I've read Julius Caesar's account of his exploits in Britain, and guess who the hero is? Yeah, Julius Caesar. Yeah, I believe he went to Britain, but let's put it this way: there is very, 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 very little physical evidence that you can show for that. All you have is his account of what he did. I don't believe there are other contemporaries. You don't have the account of the Britons talking about what he did when he was there. Maybe Caesar exaggerated a little bit and things. So we have to take that into account. But there are ways in which we can either have more or less confidence in the historical accounts that are given to us. And I personally see plenty of reason to take the historical record that Moses wrote about things like the Exodus, for example, to take that seriously. One of the reasons that I take the historical stuff in the Bible seriously is because they record the good and the bad. Yeah, it's not like the Egyptians who record the good and maybe some good that never really happened. They have nothing but victories, and that makes you, especially when you've got other accounts that are saying, well, maybe they weren't quite as victorious as they like to say they were. There are multiple reasons why I find the Bible useful when it comes to science, both historical and also experimental science.
Nice, good introduction for our discussion today. And I prepared some questions about theory of evolution, and many friends helped me to combine them. So yeah, let's start with the first one. If intelligent design or creationism is a truly scientific theory, can it be falsified? What specific evidence could refute the idea of intelligent design, and how would such falsification be tested? Yeah.
Yeah. This is actually sort of many things all sort of cobbled together. So I hope that I'll be able to give a reasonably coherent response. Number one, intelligent design is not creationism. Okay, and it's very that should be very clear. Creationism is based on faith in the Bible as God's word. Okay, and so intelligent design is not based on some book or historical account or anything like that. Basically, what intelligent design says is that there are certain patterns, certain things in the universe that are best explained in terms of intelligent causes. And so let's see here. These glasses, the ones
Oh,
I'm
would you
not
call it?
wearing.
Oh, yeah.
These glasses, they have certain characteristics that, at least to me, suggest they were the result of an intelligent cause. So they take advantage of natural laws, the laws of physics and that sort of thing. But there are certain characteristics that they have that if I found those in the middle of a field, or if I was an archaeologist and I was digging away and I came across those, I would suspect that somebody had been there before me. Um, uh, Archaeology is essentially, you know, a field of science that, while I'm sure most archaeologists wouldn't necessarily put it this way, essentially what they're doing is intelligent design. One of the standard jokes among archaeologists, apparently, at least some of the ones that I've been around, is if you find three stones in a row, you've found a wall. I have to admit, I look at some of those rocks that they say are stone tools, and wow, I'm not seeing it. So there can be a little bit of fuzziness in some areas, but intelligent design is not it's saying we can rely on what we observe and what we and using inductive reasoning to arrive at what we consider to be the most reasonable explanation for this phenomenon that we're trying to explain. It's very important to understand that intelligent design isn't claiming that everything is a result of intelligent causes. And so this so now let me jump to the question of how are we going to come up with some sort of demarcation between what we call science and what we don't call science. And first of all, let me note this. Most people, when they think about things, do not care whether something's classified as science or not classified as science. What we're interested in is what is true. Science is a method of figuring out what is true. Now, there's a famous and I think very wise philosopher of science named Karl Popper. And Karl Popper is the one who came up with the criterion that to be scientific, a theory must be falsifiable. And that's a pretty good criterion. It helps you differentiate between, conspiracy theories and other crazy stuff and serious science. So he certainly came up with that as a way of telling the difference. And I would say, you know what, most of the time I'd agree with it. However, science, is not necessarily true. And I know that may sound like a heretical thing to say, especially for somebody who has dedicated as much of his life as I have to being a scientist and teaching other people how to do science and so on. However, the entire history of science is the history of scientists being wrong. That's so on the one hand, I do believe that science is a great method for figuring out truths about nature. However, we know that using the methods the scientific method does not guarantee that we're right all the time. We can never have all the data. We can never, we can use logic perfectly and still be wrong. These are so I don't want to say, well, ignore science, but I do want to say, be careful and be open to new discoveries and new interpretations of data and new data that comes in and makes us reevaluate everything. Does that make sense? So
Yeah.
My point with intelligent design would be, I think that these guys are actually being helpful in helping us see that there are some things out there in nature that are not well explained in purely materialistic terms and are well explained in terms of some kind of intelligent cause being involved. Yeah. So I'm certainly not close-minded about that. I should tell you that there are creationists who think that intelligent design is of the devil and something that is a display of a lack of faith, and I don't know, any number of other things. There are some Christians, some theistic evolutionists, for example, who believe that God would never prove his own existence because we're supposed to believe in him on the basis of faith or something, which they have strange definitions of from my perspective. But to each their own. I would say that, at least from my perspective, intelligent design certainly makes you ask questions that you wouldn't necessarily ask otherwise. And at least in that respect, it's a good thing. It's a very good thing, because being forced to see things from a different perspective is often very helpful when you're trying to figure out what's true.
Would you even call intelligent design a scientific theory, or maybe is it a combination of a philosophical approach or theological method or something? So maybe some kind of interdisciplinary method rather than only scientific. Would you say like that?
Yeah. I guess for what I would say is, again, I don't care. It might be, if some people want to say it's scientific, great, good on them. If some people want to say it isn't scientific, it's still irrelevant. I'm interested in what is true, and it looks to me, having read some of these guys, and some of them are friends. I don't like I I don't even like to refer to it like that. Some of them are friends. No, I know these guys. I like them. I know that they are very, very smart, and I know that they are very interested in figuring out what is true. Even if they haven't gotten things perfectly framed, um, this looks to me like a step in the right direction. Let's put it that way. Um, because it forces us to consider multiple competing hypotheses about things, particularly historical things. And whereas if you're coming at these things from certain other philosophical positions, so take, for example, a materialistic approach where you believe, you insist that the only reality is matter and energy. Well, that kind of forces you to certain answers that may or may not be correct. Whereas intelligent design allows you to consider whether or not intelligence is a cause or natural laws are a cause, and so on. So it just makes you step back and take a deep breath, and then at least consider why you might be coming down on one side of one explanation versus another.
Great. Okay, can we get back to our question? What are requirements to falsify that theory, intelligent
Yeah.
design? Yeah.
Well, like I said, I'm not really in a position to argue this is science, and or to argue that science is only characterized by um, the ability to falsify. That's a really good idea. Okay, it's a very practical one. However, um, each person has to decide, uh, number one, whether that is the exclusive criterion that you're going to use, Popper's criterion, and number two, what does it mean if something is science? Does it mean that it's true? And I think that uh, uh, suggested already that it doesn't necessarily mean that it's true. It's a it is a good criterion for looking at theories, particularly when you've got people saying crazy stuff, right? So somebody comes along and they say this is science and you must believe it, okay? Because science is true. Well, science isn't true. Science is our best understanding at the moment, based on what we know, based on what we've observed, based on our current thinking about things. This is our best understanding. But let's not become like, I don't know how familiar you guys will be with Anthony Fauci, who's standing up and saying, "I am science, and therefore you must believe me." No, you know, um, uh, I have had the privilege in my life of meeting many, many fantastic scientists. Okay, in fact, quite a number of Nobel Prize winners. Before he died, I had the privilege of and I hate this sort of name dropping nonsense. Okay, I wasn't Francis Crick's buddy, but we went to meetings together. We had conversations together. He was always extremely nice to me. And I remember very shortly after I had graduated, I was at some meetings with Francis Crick. Now, Francis Crick got a Nobel Prize for figuring out that double helical structure of DNA. And he and Watson, Jim Watson, whom I've also spent a little bit of time with over the course of my life. But Francis Crick, he really uh, impressed me with the humble way in which he, um, came at things. I remember being at some meetings with him, and again, this was shortly after I, gotten my PhD. And if you've done it right, if you've done a science PhD correctly, you um, find yourself graduating in a state of panic because you realize you know absolutely nothing. Um, you just learn that pretty much how little you know. And so I was saying to Greg, um, wow, I'm really having trouble understanding some of these presentations. And his response to me was, you know what? I'm chairing some of these meetings and I haven't a clue what these people are talking about. So don't be science is not about having all the answers. It's about having curiosity and being excited when you find something that looks promising. And so, but also understanding, you know what? Someone's probably going to come after me and find out something else that puts a whole new perspective on this. And it's not the destination; it's the journey, and it's a wild one. Um, uh, it just seems like half of what I've learned over the years um, has been superseded by something that's far better in the course of my academic career. That can't be half, surely, but I don't know. So much. And that's what makes it fun. It's not like English literature. The words never change. But anyway, that's beside the point. Uh, this is what makes science great. We talk about it being constantly, self-correcting, and and of course, it isn't as perfect as you would like with things like that. But it grows and it changes and at every iteration, it's more amazing than it was before.
Amazing story and answer. So, just quickly, let me ask you about what people like Francis Crick and other that you mentioned, what they think about creationism. Is that funny theory to them, some pseudoscience, or do they respect or something like that?
Well, Crick particularly was an atheist. I don't think there's any secret about that. Um, uh, Interestingly enough, he did realize that the theories that we have, the materialistic theories that we have for the origin of life on Earth, are inadequate. They, um, what I think that I hope that a majority of your listeners would understand that most of this origin of life stuff is, it's just high school chemistry, it should give you enough knowledge to understand this is not the way reality works. Um, but so anyway, he realized that there simply were not the probabilistic resources and the kind of chemistry and things that you need to get life on Earth in the time that we have. And also that on Earth, life appears far too early. There are papers out now that are claiming that the first signs of life are over 4 billion years ago. Well, by most conventional understandings of how the Earth formed, you have all of this matter kind of coming together, all this dust and so on, has a lot of energy to it. So the Earth forms as a molten ball somewhere around 4.5 billion years ago. And it takes about 500 million years for it to form a crust on it. It seems pretty obvious to me that life is not going to form on molten rock. That's just not the way things work. So, and yet, right? I mean, the instant we have a crust, there is evidence of life on Earth. And some of that might be data, that's being misinterpreted or something. But some of it has to do with things like when you're looking at carbon deposits, these little bits of carbon that you can find in zircon crystals. The isotopic ratio suggests that carbon was a product of photosynthesis, which is immensely complicated, and did not evolve in a matter of a very few million years or 100,000 years or something like that. It just didn't do that. So Francis Crick, he looked at these things, and to his credit, he came up with or suggested that we should take seriously the idea of panspermia, the idea that somehow or other life came from outer space. The problem, obviously, I don't find that to be a particularly satisfying explanation myself, but you know what? That's probably the best materialistic explanation of where life came from. Although all it really does is it just makes the problem more remote. And for better or worse, with materialistic theories about things, a lot of that goes on. When the data point in exactly the opposite direction, then the events that we're trying to explain are made more remote and placed further beyond examination, is how I would put it. But anyway, so Crick was an atheist. Francis Crick was an atheist, but he was an atheist who I really respect, and I believe an atheist who was willing to look at data and try to come up with some alternative, reasonable explanation for what we observe here on the Earth.
Great. Thank you so much. Let's go with another question. Which phenomena can intelligent design explain that evolution cannot? Is there such an example?
Yeah.
Does ID have hypotheses that can be tested through observation and experimentation, similar to how the theory of evolution encompasses various fields such as genetics, the fossil record, and biogeography?
Yeah, two observations. First of all, of course it does. what you can do is you can look at something like the algorithm that someone like Bill Dembski put forward for telling, at least in a general way, the difference between design things versus things that are a product of natural causes or just a product of chance. Because remember, chance is something that is real, and unlikely things happen all the time. So he does a fairly nice job of sort of splitting things into those three potential causes and coming up with criteria for why you might come down on the side of an intelligent cause for something, whether it's natural or not. And yeah, you could challenge that algorithm with various things. Probably, in my mind, at least a reasonable example might be something like quartz crystals. Quartz crystals, they're quite beautiful. They're very regular. There's you can see that there's a repeating pattern with them, and so in some ways they look like something that somebody might have made. So you can go and you can test that theory using Bill Dembski's explanatory filter and see whether the explanatory filter works to point out that no, those quartz crystals are actually a product of natural processes. And so that would be, so of course you can do that. Does that mean that I believe that there's no possibility of a false positive versus a false negative? No. Any algorithm, it's not, invincible. Occasionally, you're going to come to the wrong conclusion about things. Human beings have a long history of doing that. One of my favorite examples is the example of people thinking they saw canals on the moon. Sorry, on Mars, and based on their observation of these canals and the maps of those canals that they drew and everything, they were absolutely certain that there was some kind of civilization that built canals on Mars, and it's all complete nonsense. It was all based on their imagination, because when you get clear images of Mars, there are no canals there in the first place. So yeah, human beings can draw wrong conclusions and be deluded and all sorts of other things. We're very fallible creatures, but that doesn't mean that the logic is necessarily wrong or not useful. I mean, an algorithm that can tell the difference between designed things versus things that are not designed, better than 90% of the time, can be kind of useful. It can be useful for many, many, many different things. Solving crimes, for example, particularly financial crimes. I have an uncle who, works in solving financial crimes, and they're looking for certain patterns in data that should be pretty much random. And when you see those patterns of some kind of interference, then there's an intelligent cause, and they're doing something naughty. So this logic, it's not like it's some kind of crazy fanatics thing. It's used all the time, routinely. It's just that we don't like to apply it to stuff that we classify as natural. And why is that? Well, often enough, it's because it impinges on some religious commitment that we have. It's nothing to do with science. We might define science in materialistic terms or something, but materialism isn't my religion, and I don't really understand why it would necessarily be anybody else's religion. But certainly you see people acting as if it is. And by the way, let me also point out that when it comes to religious things and worldviews and stuff like that, they explain everything. So when people talk about things like evolution, can't explain, followed by whatever it is, of course evolution can explain whatever that thing is. It's a question of how satisfying is that explanation really? Remember, evolution can act like a religion. I'm not the first person to say that, by the way. It can act like a religion, and people's entire reality becomes dominated by the necessity of explanations that are consistent with certain materialistic assumptions. And so it doesn't matter how much like a fairy tale the story sounds, or unreasonable the story sounds. It must be true because it's materialistic in some people's minds, rather than following something like Occam's razor. Let's say people pick and choose their criteria.
Okay, nice. Another question. How does intelligent design explain the existence of rudimentary organs such as pelvic bones in whales, which have no clear function in their current form but are consistent with a gradual loss of function throughout evolution? What role do these structures play according to the ID, and why wouldn't God remove them entirely?
First of all, there's a kind of logic that comes up very, very frequently in these discussions, and it goes something like this: we don't know what this does, therefore it does nothing, therefore evolution is true. The flip side of it is that people will claim that evolution has gotten rid of, certain important things along the way. So, maybe, evolution on the one hand can get rid of structures, but in this particular case, evolution hasn't gotten rid of a structure. It's something to do with the pelvis and I think femur. I think there's a little rudimentary femur in some whales, at least, as well. And here's the way. Well, first of all, there's a concept in evolution called co-option, right? And the idea of co-option is that a part that was evolved for one purpose, it had one purpose, may on occasion be taken and used for another purpose. Why a creator couldn't do that beggars the imagination. But in the case of whales, and I don't claim to be a whale expert, okay, but my understanding is that in the case of whales, those bones certainly serve as attachment points for muscles and tendons and things like that. And so they are actually doing something pretty important, particularly and perhaps embarrassingly when it comes to their penis. So you take those things away and there's no mating, and no mating means no more whales. So it's probably best that they be kept there. Here's the problem, and this sort of illustrates an issue with evolution, which is sometimes thrown at the idea of intelligent design, and that is evolution has a tendency to explain everything and nothing. So if those bones have a function, then that's why they're there, because selection keeps them there, right? But if they have no function, then it's somehow or other proof of evolution, because God wouldn't have done that. And that's a theological argument. You see these theological arguments used by Charles Darwin continually throughout the origin of species. Remember, he trained as a theologian, so it's not surprising that you would see the sort of "why would God have done it that way" argument. And of course, God can do things any way He wants. And let me also just point out, one other thing that sort of points out something. You've got a whole bunch of the questions that are difficult for creationists. I don't have the answer to every question. Okay? I don't claim to. As a Christian, I live by faith. Having said that, there are just as many questions that are, I would say, unsatisfactory in the answers that are offered when it comes to evolution. Look at the supposed evolutionary history of whales. They're supposed to have gone from something not a wolf, but something kind of wolf-like, and 9 million years later be these 100% marine organisms with a jillion adaptations, complex rearrangements of their anatomy and their physiology so that they can survive in the ocean and give birth underwater and do all of these sorts of things. I mean, 9 million years? Are you kidding me? That's just a huge, slowly reproducing organism in 9 million years. I mean, there's supposed to be 6 million years that separate humans and chimpanzees. If that's how much you get in 6 million years, how do you get what you've got in whales in only 9 million years? Behavioral differences, just everything is different. Their ability to dive to incredible depths and come back up without getting the bends. You just go on and on and on and on and on with all of the changes required to become a whale in only 9 million years. yeah. I'm happy to sort of struggle with some of these questions and to let you know if I don't have anything to really add to the discussion. But keep in mind, um, while these may seem like difficult questions, I think they pale by comparison with well recognized problems like Haldane's dilemma and so on, which I keep being assured every few years has been addressed and hasn't. But anyway, let's continue on and do another question.
Great answer. And yeah, let's do humble apologetics like Ronnie Nalin said. Yeah, I
There we
like
go.
that. Now, if macroevolution doesn't occur, how do you explain the transitional fossils that show gradual changes over time, like Tiktaalik for fish to amphibian evolution, and many other? But yeah.
Yeah. I'm just trying to figure out this question is presenting an interesting piece of data, but a false pattern. One of the repeated patterns in the fossil record is the sudden appearance of major groups of organisms, and not the gradual appearance. If you don't believe me, go and read chapter 6 of The Origin of Species. Charles Darwin recognized this and he wrote about it. There are not gradual transitions in the fossil record. Even those sort of classic ones that have been put in textbooks like horses, for example, are now recognized as simply not being right. picking organisms out of different strata, so at least with the conventional interpretation, different periods in time, and sort of lining them up in the most reasonable looking sequence. But no, things need to appear in the fossil record, and then the ones in between need to be intermediate. And that's what you do not see. What you see is sudden appearance of fully formed organisms. Birds are a beautiful example of this. What you generally see is when these major groups first appear, they are there's greater diversity at a fundamental level. So with birds, you may have heard of something called Archaeopteryx. You've got it's a bird. It's got a bird-like brain. It's got feathers and so on, but it has a long tail. It's got teeth in its mouth, and this is one reason why some people think that birds and dinosaurs kind of go together, and that dinosaurs may have had feathers as well. By the way, I've seen some pretty good dinosaur fossils that do look to me like they may well have had feathers on them. Others are kind of marginal, but some, no, they're pretty good. But in any, as a creationist, it doesn't make any difference to me whether or not dinosaurs had feathers on them or not. But anyway, getting back to the birds, you see there at the top of the Jurassic layer of rock there, and the layers immediately over the lower Cretaceous, you see birds appear globally. There are examples from Spain, I think at least one from Australia, a whole lot in Mongolia, China, Germany, obviously, where Archaeopteryx came from, and so on. I mean, these things just boom, they're everywhere. But and you have modern birds appearing with them, okay, the neo-ornithians. But you have these other strange birds with teeth in their mouths, birds with little fingers and claws on their wings, birds with longer tails, birds with different kinds of designs to them. You see birds with very different breastbones, and that kind of interests me. To me, it suggests something different about their ecology. And you see some modern kind of analogs, but not identical to these things. I'd love to see some of them alive. But in any case, the point is there's this great diversity, and now we have less diversity. We have basically one kind of bird, but we have lots of different little differences between these birds. So you do not see gradual evolution of birds. You see sudden appearance of birds. You see the same thing with mammals. You see certainly the Cambrian explosion is the classic example of just all this stuff, even vertebrates, by the way, appearing, boom, without obvious ancestors prior to their appearance. So you do not see these what Charles Darwin called, I think, a gradual organic chain. You just don't see it. His explanation for that was that the fossil record is very imperfect. But that's, to me, that's like saying the data don't agree with me, therefore the data are wrong. But I don't like that kind of logic. Anyway, I hope that this has sort of been helpful. But let's talk about Tiktaalik specifically. The idea with Tiktaalik is that it is supposed to be an intermediate between fish that exclusively swim in the water and quadrupeds that walk on the land. And the bottom line is there are trackways that are much older than Tiktaalik, certainly in much significantly lower layers that show quadrupeds walking. So Tiktaalik can't have been intermediate on its way out of the water. There were already animals walking around out of the water. Precisely what was going on with Tiktaalik, I can't tell you. But I do know that there are plenty of strange and amazing creatures out there in the world. I come from Australia, platypuses. You don't get stranger and weirder than platypuses. But they're clearly not intermediate between some ancestor to mammals and the mammals that exist today, because they're here with us and we don't see them in the layers of rock where we'd expect to see them if they were ancestral to us.
Awesome. You mentioned Cambrian explosion. We see sudden explosion of many fossils and organisms, but evolutionists have maybe 10 or more theories or hypotheses how they explain that sudden appearances. So can we say that maybe?
Oh, by the way, there's one other thing that's worth mentioning. There's also sudden disappearances, and yes. I think that the general consensus is that there have been 5, maybe 6 major extinction events over the course of history that we see recorded in the fossil record. My suggestion about that would be that doesn't it seem like a miracle that when we're wiping out 90-something% of all the living things, and we do that over and over and over again, and we never quite get to 100%. How lucky we are that we've kind of gone right to the brink over and over again. To me, that seems like a pretty extraordinary explanation of the fossil record. the fact that there are people who um, claim that there's no evidence of a global catastrophe like the flood, Noah's flood that's recorded in the Bible. I mean, that just seems extraordinary to me. Here you've got, you know, on the one hand, people saying 6 global catastrophes that nearly killed everything, and the Bible, records one global catastrophe with a mechanism for preserving at least the land animals. And people say, "Oh, no, no, no! There's no evidence of that." Anyway, um, and I think there's plenty of evidence actually for anybody who, uh, you know, isn't blindfolded to see of some kind of global catastrophe that involved water. Anyway, that's beside the point.
That's crazy. Yeah,
Yeah.
nice. And yeah, I wanted to ask, is theory of evolution also unfalsifiable? Because you can propose
Yeah.
many hypotheses to explain Cambrian explosion and others.
Yeah, not only that, I mean, what you see is that uh, no matter what it is, it will still be called evolution. So if something lacks a known function, that's proof of evolution. If something has a known function, well, that's evidence of natural selection working on it. If something, if two organisms have the same thing, or something very similar, then that's evidence of convergent evolution, right? Um, there's, there's all, there's just sort of, it's like an observation plus add evolution onto the end, and somehow or other it makes it a logical product of evolution. I'm fascinated by the invocation of things like horizontal gene or lateral gene transfer. The idea is that evolution explains things in terms of vertical inheritance of genetic material, except then you have genetic material that just shows up in the wrong place, and all of a sudden, is so when you find a gene that simply shouldn't be there in an organism, does that disprove evolution? Of course not. No, we invoke another hypothetical mechanism that seems pretty extraordinary. You know, one of my favorites has to do with uh, bilirubin, which is the stuff that turns people with liver problems orange. Um, it's a normal thing in human beings in the recycling of hemoglobin, and this is happening in your liver. And if your liver isn't working properly, you get this orange pigment building up inside you. The problem is that bilirubin also shows up in these bird of paradise flowers in a plant. Um, it's uh, it's just in the wrong place, you know. So how do you explain this? Well, it must be horizontal gene transfer or something along those lines. Um, but precisely what mechanism would take the mechanism for producing bilirubin out of animals and put it into that particular plant, which would then figure out how to use it as a pigment to color its seeds, is pretty incredible. Um, you know, like all of these things have explanations. What seems reasonable? Okay? And what causes you to see some explanations as more reasonable than others? Is it some kind of blind faith in a theory? Is it some kind of unquestioning acceptance of something like materialism? Or is it some crazy other religious kind of belief? Or are these explanations really satisfying? And I would say this, by the way, for both sides of these sorts of things. If we're talking about evolution versus, people who believe the Bible or whatever, we always have to be asking ourselves, is that really a satisfying explanation? Just because we've got an explanation, is it really satisfying? I mean, sometimes some explanations really have a ring of truth to them. Others have a ring of desperation. Yeah.
Yes, I agree.
Yeah.
And are you maybe open to some kind and extent of macroevolution at even small level or scope? Because,
Mm.
yeah, maybe we don't
Mm.
have a common ancestor, but maybe some small macro evolution happened. Do you
Well,
see option?
here is what I would say in general about um, evolution. Yeah, evolution has many, many different meanings. People use that word in over a dozen different, over 10 or 12 different ways. And so when you're talking about these things, you do need to be quite careful. If we're just talking about change over time, um, I believe that, again, a careful and reasonable reading of the Bible requires that we believe that organisms have changed over time. Um, uh, you know, uh, I people don't live for hundreds of years anymore, but they're recorded to have lived for almost 1,000 years um, early on. So something has changed, and precisely what that is, I have no idea. But there's a record there, and if I wish I knew what the mechanism was, because if then it might be reversible or something like that. But whatever the reason, things have changed. There are some other things in Scripture, like twice God gives this command to humans and also then to the animals to go out and fill the earth. Okay? So after Noah's flood, um, this is the command that God gives to the animals, and um, it would be ridiculous if God was commanding them to do that if they didn't have the ability to adapt to different environments as they spread out. Um, you know, so it it should not be surprising to find that animals are remarkable in their ability to adapt to different circumstances. I mean, look at bears. Um, uh, there's no doubt that grizzly bears and brown bears are basically the same thing. They happily mate with one another and produce offspring in the wild. So they're pretty much the same thing, and yet a grizzly bear is quite a different thing from a polar bear. I mean, it's not just that they're different colors or something like that. Their behavior, their diet, their size, um, just everything. In fact, I think polar bears are about the only, one of the very, very few wild animals that will actively stalk and hunt human beings. Um, don't want to be messing around with those. But they are very, very well adapted to very cold northern regions. Um, and you could say the same thing about Arctic foxes versus regular foxes that live around throughout Europe and also here in North America and so on. things, organisms definitely have a remarkable capacity for adapting to different environments. Whether or not that is by the mechanism that of mutation and selection is a whole other question. And whether or not that accounts then for, the origin of elephants versus humans or something is totally different as well.
Great, thank you so much. Now, if Dimetrodon and dinosaurs were created independently, why do they have similar features such as back sails and comparable holes in their skulls? Doesn't this suggest evolutionary convergence through shared ancestry or adaptive processes supporting macroevolution?
That question, I'll say a couple of things about it. One, it's a little bit outside my area, but so I don't want to, sort of pontificate on it. But I think you may have things a little bit muddled there about Dimetrodon. There, yeah, I'm not sure that they're seen as a product of common ancestry with what was the other species?
Yeah, dinosaurs. I don't know
There's
which one.
some dinosaur. Um,
Yeah.
there is. I think Dimetrodon is supposed to be ancestral to mammals, and but I really kind of would prefer not to go down that particular black hole, pretending that I know all of the details. What I would say is um, this might be a nice example of evolution explaining everything and nothing. Um, you know, similarities are supposed to be accounted for by inheritance from a common ancestor, but there are plenty of cases where that can't be done. So instead of saying, well, then evolution isn't true, it's convergent evolution that's just sort of invoked. Um, uh, yeah, I'm familiar with these organisms having these sails. We don't know what they did. Some people speculate that they had to do with regulating heat. Um, who knows? Maybe it was that. Maybe it was showing off to ladies to get a mate. Who knows? This is an example of how we can't go back in time with historical science. We can't probably can never know what color they were. We can't know many things. So just sort of waving a sort of wand and saying convergent evolution to me is not a particularly satisfying thing. It's much better to know that you don't know something than to think you know something when you don't. It's less. Sometimes I go and speak at churches, and every church has at least one person in it who knows everything, and they're really the most boring people in the world. Very tiresome to put up with. Nobody knows everything, and I certainly don't know about this particular thing. So I won't waste more time with it. But admit it when you don't know. It's okay. And by the way, don't run to the nearest textbook or something and think that you're going to get the correct definitive answer either. You might be just getting that author's speculation about stuff. And speculation is just a placebo for knowledge. It's not real knowledge. So anyway, let's continue on.
Awesome. I encourage our viewers to not look this interview like a bazooka that shoots theory of evolution and destroy completely, rather just some insights and maybe some questions and thoughts. Yeah. So this is a bit longer question. If Homo sapiens and the Neanderthals were created as separate species, how can the fact that modern humans carry specific Neanderthal alleles in certain genes, for example, for immune response and adaptation to cold, be explained? This genetic correspondence is not merely superficial but extends to the same exact sequences, indicating a genetic crossover between our ancestors and Neanderthals. Svante Pabo, or how you pronounce, I don't know,
Pabo,
received
Pabo, it would be. I think
Pabo,
it's
yeah,
Pabo is how,
yeah, I don't know him,
yeah,
sorry,
yeah.
received the Nobel Prize in 2022 for his research showing that Denisovan DNA is present in certain Asian and Australoid populations, which suggests the existence of multiple groups of archaic humans that interbred with early Homo sapiens. How does this complex pattern of genetic exchange get interpreted, especially considering that these groups share DNA with certain temporal and geographical frameworks confirmed by radiometric dating of fossils? I'm tired. Yeah.
Yeah, there's an awful lot there. Um, again, this is an area that's a little bit outside my area of expertise. Um, certainly, I don't assume that Neanderthals and and what we call modern humans were created separately. And I want to be really, really careful about that because this sort of thing is the foundation for a lot of really racist kind of thinking. Um, uh, yeah, um,
So you
I
don't mind if you
yeah.
have evolution from Neanderthals to modern humans, you don't mind that, or yeah.
Well, or whatever, the human fossil record is like these other examples that like the bird one that I gave you. Ancient humans are more diverse than modern humans. And that's exactly the opposite pattern to what Darwin predicts. Um, we should have one thing splitting into something different, but instead, we're finding these Denisovians, we're finding these Neanderthals, we're finding early modern humans, and so on, and we're kind of uh, trying to figure out exactly what to make of them. It's really interesting that we've been able to get some DNA sequences out of these things, and to find that in fact we modern humans do have sequences that we share with those ancient human beings. Um, my understanding, and again, this is just from limited reading of what other people have said about these things, is that um, a lot of these genetic differences probably built up rather rapidly in tiny populations. So you get massive amounts of inbreeding and so on as you've got these little tiny groups going and spreading out across the surface of the earth, which is what you would expect, again, according to the way the Bible describes things. Um, I personally feel no shame at having a small amount of Neanderthal DNA in me. Um, you know, I wish it meant that I felt the cold less, but there you go. I was personally shocked when I started looking at my own DNA and found out that even though I am primarily of uh, Northern European and a little bit North African, um, and a little tiny bit Native American even, in my DNA makeup, um, that my percentage of Neanderthal is way lower than the average European. So I don't know why I missed out, but it varies. It varies around apparently quite a bit. But there you go. Um, the bottom line is these. I believe that Neanderthals were, you you probably wouldn't recognize one walking down the street. Um, that's if you could pin them down and start examining them, you might be able to tell them apart based on, I don't know, brow ridges and lack of a prominent chin and a few other things. But pinning them down might be a struggle. They look like they were stronger than us, and they had, by the look of it, larger brains than we have. So I'm not ashamed of getting some of their DNA. Maybe they gave me just a little bit more brain. Who knows?
Yeah, okay. So Neanderthals, that's whole topic for itself. But yeah, we
Yeah,
should
yeah.
continue. How can the existence of long terminal repeats, LTR, retrotransposons, specifically human endogenous retroviruses in the human and chimpanzee genomes be explained when certain sequences are found at identical locations, indicating that they were present before the human and chimpanzee lines diverged. If humans and chimpanzees were created independently, one would expect them to have a different LTR retrotransposons in different locations. Yeah, here again we have
Mm.
a presupposition that they are created separately, but you answered, yeah.
Yeah. I personally believe that chimpanzees and human beings were created separately. Um, that's a pretty theological argument that God wouldn't do it that way. Wouldn't put retroposons there. Um, and it's actually a fairly typical example of how people pull in theological presuppositions. I guess you could say, now, don't. This is not my answer, okay? But I guess you could say, well, God can do anything He wants in any way that He wants. Um, Fairly recently, it's become quite ob well. Let me start off with noting this. Uh, these endogenous retroposons, basically, the theory is, or the interpretation is, that these are basically virus sequences that have been inserted into the DNA, and that then over time they have been degraded because natural selection isn't working on them. I'd note a couple of things. First of all, uh, when you do experiments where you put DNA into organisms, it's pretty typical that they will have spat that out within a few generations. It'll be gone. Um, so stuff that isn't supposed to be there goes pretty quickly, normally. Why so many copies of these would remain is, if they're just there doing nothing except showing that God didn't create humans and didn't create chimpanzees, is a little bit It's not what you typically observe. Um, when it's the yeah, I mean, we're talking about something like 8% of the human genome. And I would expect, yeah, I don't know for certain, but I would expect we'd be looking at a similar proportion of the chimpanzee genome. Um, so it may be that just by chance you're going to get some of them in the same place when you're talking about 8%. But for me, at least, um, the fact that these things have been shown to be functional in various really surprising ways is, sort of um, calls into question the logic that these things do nothing. So therefore, they're just markers of historical events. Um, they, for example, they have been shown to play a very active and significant role in our resistance to viral infections. So that's a pretty big job. In addition to that, probably the most surprising thing has been the role that they play in the formation of human placentas, um, which is pretty important. What with us being placental mammals, um, it's not that there are not potential evolutionary explanations for these things, but I don't see them as being, um, you know, out of the ballpark evidence that that God, in fact, didn't do things this particular way. One of the one of the things, and again, okay, I'm going to just step back and I'll give you a kind of a speculation warning, but something to be looking for in the future as we come to understand genomes just a little bit better. Um, we used to view genomes as fairly static things, like a library. And there's these books on the shelf, and each shelf is a chromosome, and maybe each book is a gene or something like that. But genomes are looking like they're much more dynamic things, and it may be that these retroposons are playing some kind of role in that dynamic thing. Some organisms, I'm not saying 100% or whatever, some organisms have been shown to greatly increase the mutation rate of at least some of their genome. It usually appears to be targeted in some way when they're placed under stress. And you have things like transposons, which are a different thing, but um, they have similarities, moving around in genomes to change the way in which genes are expressed, and all kinds of stuff as they respond to stress in the environment and so on. So maybe these are, some kind of mechanism for that. That's speculation. Like I said, I wouldn't put that into the take it to the bank thing, but keep an eye out for um, this, what I think is an emerging different view of genomes and how static they are versus how dynamic they are in real life. It may be that these things play a role with that. Also, just be on the lookout for um, arguments that the logic just isn't that great. Or I put this into that category. Number one, God wouldn't do it that way. Well, how would you know? you know How would I know how God would do things? Um, unless he, announces it to us publicly or something. Um, that would be, one what I call fairly standard spurious argument. And then another one that I already pointed out, which is we don't know what these do, therefore they do nothing, therefore evolution is true. Um, Certainly these things do something, and if they are functional, then there could very well be functional reasons why they appear in certain places. Um, but do I find either of those explanations, the boy, super satisfying one that's backed up by everything? No, I don't. Um, uh, so these are things that um, and it's often worth doing this in life. Just sort of let things set for a while, see what bubbles up through the scientific literature. Something interesting comes along often enough. I know that a fair number of the things that really challenged me when I was younger have kind of turned to dust over the years. Um, and one of them is the idea of junk DNA. I was, pretty enthusiastic about Richard Dawkins' ideas about selfish genes and so on. It all made so much sense until it didn't make any sense anymore. Yeah. Anyway.
Yeah, good example. Maybe sometimes we should just wait. In
Mhm.
archaeology is the same. Yeah, so nice.
Yeah.
Um, this is hard one, but yeah, all
All
those are
right.
hard. Yeah.
Fire it
Uh,
at me.
if species were created independently, how do you explain ring species? Yeah, that's the
Mm.
where populations around the geographic barrier can interbreed with neighbors, but not with populations at the ends. What other than gradual evolution explains this continuum?
Uh, yeah, that's I'm kind of interested in this one because I'm not sure that I truly follow it. Um, I don't have a problem with systems falling apart over time and under different selective circumstances. So um, an example of a ring species, this is sort of the simplest one I can think of off the top of my head, is certain uh, gull species. If you start on one side of the world and they spread in both directions, by the time they get to the other side of the world, they do not interbreed with one another. But you can trace them all the way back to this ancestral population that does interbreed, obviously. Um, so, so what's going on there? Um, I suspect, given the number of things that have to go right for things to interbreed, that um, uh, it's pretty easy to reproductively isolate things. I suspect. Um, uh, you could do that, for example, with dogs. I suspect if you put, I don't know, male Irish wolfhounds in with Chihuahua, female Chihuahua, you're probably not going to get any offspring. And uh, so, there's there are many ways in which reproduction can go wrong or be changed. So personally, I don't see that as being a particularly impossible challenge. Reproductive barriers, either physical or physiological or whatever, shouldn't be, at least in theory, all that hard to develop. However, let me give a counterexample to that. I was recently in Turkey, and I was admiring there the um, they're called oriental plane trees, Platanus orientalis. The reason I'm interested in them is because here in the United States we have sycamore trees, which are called Platanus occidentalis, and these trees grow under quite different conditions, obviously thousands of kilometers from each other. In theory, they're separated by something on the order of 50 million years. So in 50 million years, in different parts of the world, under different selective pressure, under, all sorts of things like that, and they've developed into different species, except when those two trees were growing near one another in the botanical gardens, I believe it was in Oxford, in England, lo and behold, they interbred and produced something called the London plane tree, which you see growing in cities all over the world nowadays. Very, very hardy, good tree for growing, and it's a very attractive tree. So let's see here. If one species can, over the course of time and distance, lose the ability to interbreed with itself, if that's proof of evolution or evidence for evolution, what is it when two trees separated by 50 million years and, halfway around the world from each other can interbreed with one another and produce extraordinarily hardy trees that do very well in polluted cities and so on? Is that proof that evolution isn't true? And obviously, a religious evolutionist would say, no, it isn't, blah, 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 and would have all kinds of special pleadings for this. But, if you're applying the same logic, you need to
Yeah, you
come
can
to
go either way.
consistent solution. Yeah, conclusions. My point isn't to make, again, is not to make fun of people who are dedicated to the idea of evolution. I like to hear the best explanations they can come up with as well. However, each one of us as individuals does have a right, and I believe we're also blessed with a mind to watch how the logic is going and consider the data carefully, and try to try to figure out what is really the most reasonable. You might say to me, well, what is it really reasonable to believe some book that I wrote a chapter in a book some years ago, and Richard Dawkins reviewed it, and one of the things he said in his review was something about the sort of myths of a bunch of Middle Eastern camel herders or something that we're all believing. Not exactly. The Bible presents a pretty coherent and hopeful view of reality that is not unsophisticated. He also, by the way, claimed that we'd all gotten our PhDs from little-known Bible colleges deep in bush country. I still don't know exactly what he meant by that, but I know he hated George Bush. And I should mention that actually there were people with PhDs from Harvard University, Cambridge University, Oxford University, where he happens to be. So, I guess he's teaching in a little known Bible college deep in bush country, whatever that means. Uh, I, um, I don't subscribe to that kind of, I don't know, making up stuff about other people and things. But the Bible presents at least um, a logically sufficient cause for what we see in nature. And in addition to that, God himself did show up here on earth and do things like raising people from the dead and that sort of stuff, which is a pretty good demonstration that he knows what he does have the capability to make life and so on. So, it might be tempting to sort of dismiss all of that because it happened some time ago. But I don't see why you would. Um, as I said, I believe Caesar when he said he went to went to Britain. I have no reason not to believe that. And what I believe Paul when he tells us that he saw the risen Christ, and of course all the other witnesses. If it was just one lunatic, that'd be one thing. But there are a lot of people who were pretty sure they saw Jesus raised from the dead. Um, so yeah, most of them gave up their lives for that belief. My inclination is to think that they were pretty serious about it. Anyway, it's certainly been enjoyable talking about these things with you.
Yes, I enjoy also, but yeah, we have three questions to go. Do you
Oh,
have
there's
strength?
more. All right.
Or... Yeah.
let's give them a go. All right.
Okay. How does creationism explain unique species distributions on isolated islands, for example, lemurs in Madagascar or marsupials, marsupials,
Marsupials in Australia.
marsupials,
Yes.
yeah, in Australia,
Yeah.
that align with evolutionary predictions.
Mm-hmm. The bottom line is, this has to do with biogeography and where things are, and um, probably the most interesting place in the world as far as biogeography is concerned is Indonesia, the Indonesian archipelago, or what used to be called the Malay archipelago. I grew up in Malaysia, so this is reasonably familiar territory for me. You've probably all heard of the island of Bali. Uh, Bali, up until you get to Bali, you have Asian animals. Um, so tigers, elephants, those kinds of things that you have in Asia. And then there is the next island in the chain is called Lombok. And Lombok is where you begin to see Australian type fauna. There's an imaginary line between Bali and Lombok called Wallace's Line, because it was this observation was initially made by Alfred Russel Wallace, who those of you who are familiar with the theory of evolution know that he kind of beat Darwin to the punch with publishing about natural selection and so on. Actually, natural selection was not a new idea, but that's a whole other thing. Anyway, Alfred Russel Wallace was a real sort of naturalist out there, looking at stuff for most of his life. He did more than a single voyage around the world and then sit at home like Darwin. Um, anyway, I kind of really admire him for these kinds of observations that he made. There are theories about, no matter what, you have to have some way of getting the animals to those islands associated with Australia and to Australia itself. And it's a little bit hard to figure out why. Up until you get to Bali, the sea floor is quite shallow. So, of course, I think most people believe that ocean levels were lower in the past, so organisms could migrate directly across dry land to get to Bali. But there is a deep ocean floor between Bali and Lombok, and the idea is that then formed some kind of barrier that animals couldn't get across. Problem is, it doesn't necessarily explain why the marsupials got across and not the tigers, let's say. Elephants, they're pretty good swimmers. Why didn't they get across? I don't know. It is about 80 kilometers, I think, the gap. So it's wide enough anyway to have isolated things a bit. You also get changes in the vegetation too. So it's a lot more than just the animals. Australian vegetation is quite different from Asian vegetation. I know I've gone back and forth many times. The bottom line is this. People invoke things like rafting to explain the movement of organisms between land masses very commonly. Both evolutionists do that to explain island biogeography, and creationists do it. I'm not an expert. Okay? I am currently working on a study of some organisms in the Galapagos Islands, and it's pretty obvious to me that those organisms, yes, did originate from South America, as it was obvious to Charles Darwin. What is also pretty clear is while those organisms were able to adapt in various ways, they didn't adapt infinitely. Okay, in other words, you didn't have any of the lizard type organisms there evolving into mammals. You did have birds losing the ability to fly. You did have birds specializing on different diets. You do have iguanas doing extraordinary things. I mean, the marine iguanas going out and eating seaweed, diving down into the ocean for their food. That is really unique behavior, and morphologically they're quite unique. They're quite different from the land iguanas. But you know what? Even in the wild, they occasionally interbreed. Still, they haven't turned into. Like, I was shocked by that. I mean, their breeding seasons are even different, and yet occasionally you see these hybrids. So it looks to me like these organisms were capable of adapting to different environments, but not infinitely. And that was really the big debate that Charles Darwin was involved in, whether selection was capable of being driven infinitely in a different direction. It sure doesn't look like it. And by the way, that's probably why Gregor Mendel, the father of modern genetics, was looking at those peas. He believed a different theory, which was that you get different species through hybridization. And this is why in his paper, if you go back and look at it, he is directly addressing anagenesis and saying, no, the alleles, they are unchanging alleles. They never change. That's why we had to come up with mutation to make them change somehow to get evolution to work. But so you've got to kind of understand what's going on with this argument that was going on at the time. Darwin looked at some of those organisms in the Galapagos Islands and said, hey, they've changed, so therefore change is real, so therefore you can change things forever. That's a big jump. A big jump indeed. Anyway, was there one more question?
Yes, here it is. How can we observe new species arising in real time? For example, heliconius butterflies and cyclid fish, if
Cichlids,
macroevolution
yeah.
doesn't happen.
You know what's interesting? Literally, just this morning, one of my colleagues and I were going over a paper that is due on the 31st that we've submitted on cichlid fish. We've been studying a couple of species there in Lake Tanganyika. And yeah, the interesting thing about these cichlids is they seem to be capable of producing new species literally within a year. It's just, which does raise an awful lot of questions. What exactly is the mechanism here? What's going on? Because these things, they're still cichlids, but man, some of them are pretty different as well. They're different in size, they're different in certain behaviors, different in diet, different in their sort of reproductive ecology. It's really interesting, and they seem to be able to just boom, do it like that and crank out a new species. So how does that work? And I better not say what we're specifically finding before this is published. But the bottom line is a lot of this really depends on what you mean by species. As probably many of you know, the word species, like the word evolution, has many meanings. And we're not talking about, algae turning into an oak tree or something like that. But different, what I would really call these things like, it's more like different varieties of organism. What cichlids appear to have, to me, is that they seem to have what I would call pre-adaptions to differences in their environment. So, if one adaptation is needed, they have it buried already there in their genome. And they might hybridize, and bingo, out comes whatever that is. I suspect that's the case with a lot of other adaptations that we see arising rapidly in organisms. It's as if somebody has anticipated that these organisms may have a need of some kind, and therefore they have put it there ready for when the need arises. Um, and it can hide there in the background and be essentially switched off, but then switched on during a change in circumstances or when a new environment becomes available. That's sure what it looks like, which, by the way, looks a lot more like design to me, because obviously materialistic evolution doesn't have the ability to foresee potential issues in the future and be ready for that. It's one of the difficulties with evolution. Okay? For something to evolve in response to a new selective pressure, it must be able to survive whatever that new selective pressure is. So in a way, you've got to be adapted before the adaptation can occur. But anyway, it looks suspiciously like something like that may be going on with these cichlids. Certainly, what they show is that you don't need millions of years to get little tiny changes in things.
Yeah, we covered many arguments for recent life, but yeah, that's whole another topic. Can I ask you just one more? This is last, I promise, no more.
Oh, help me, yeah.
Okay. This is yeah. Endogenous retroviruses, ERV.
ERVs,
How
yeah.
do you explain the identical viral DNA sequences in the genomes of different species, indicating ancient infections before species diverged? Yeah, I don't
Yeah.
have anyone to ask this, so yeah, I need to ask you. So sorry.
Yeah, well, this is quite close to the earlier question, and I'll tell you, this is not an area that I'm particularly expert in. I can think of potential explanations like, hey, these are 8% of the genome, so some of them are going to show up in the same place a certain percentage of the time. I don't think that's the case with this particular example. Um, uh, Probably what you'll find if you actually go and start digging in the literature, which is what I encourage people to do. Don't just hear somebody give an argument and say, "Oh, well, that sounds convincing." Don't listen to me. Don't Well, I shouldn't say that. No, listen to people, but do what the Bible tells you to do. Test all things and hold fast that which is true. And in science, what that means is take the time and go and do a little bit of a dig yourself in the original literature. Hey, take a look at what's being said by serious people who have a different point of view, because I've certainly been surprised enough over the years. That 98, 99% identical to uh, chimpanzees thing. I was told that for years and years and years. I thought, wow, that's pretty powerful. That seems interesting. Oh, whoa. And then I went to the literature and I was like, just hang on a second. People are giving all kinds of numbers. What's going on here? Where did these numbers come from? And then when I started realizing how they were doing it, all of a sudden, at least in my mind, that argument kind of turned a little bit, well, into dust. I was really surprised by how weak that particular one was. Others, you know what? I've gone and taken a look at it. Well, that's a stronger argument than I thought as well. So, don't be surprised either way, but go and take a look. Um, uh, you know, do those particular endogenous retroviruses, do they really show up in exactly the same place, or is it in generally the same place? Do they really not show up in that place in any other great apes? The reason I bring that up is because, not necessarily for these reasons, I have looked at some other sequences that have been presented in this way myself. And this was quite a few years ago, but I was surprised to see that the pattern was nothing like as clean as I'd been told to expect. I'm not saying that's the case with these, but go and look at the literature. Don't be lazy, and just sort of take what somebody who is saying, or somebody's grabbed off the internet, or even what a textbook says. Certainly don't take what a textbook says. Okay? For better or for worse, textbooks are notorious for being full of rubbish. So be very, very careful about that. I'm not meaning rubbish from a philosophical perspective. I mean just wrong stuff, just flat out wrong. But once it gets into a textbook, getting it out is very hard. I'm not the only person who says this. I remember Stephen Jay Gould, before he died. Man, he wrote a very, very, very angry article about these embryos that Ernst Haeckel had drawn, that supposedly showed that all the embryos of these different vertebrates, pigs and frogs and chickens and all sorts of stuff, that they all kind of looked the same, and then they sort of diversified. He had this theory about how they were replaying their evolutionary history, which I don't think anyone believes nowadays. But the point is, over 100 years ago, people knew those were false. They were a product of Haeckel's imagination, not of reality. You look at photographs of these things, they don't look remotely like what he drew. But his drawings appear in textbooks up till this day, textbooks I've used. So, do reasonable diligence. Try to dig into the literature yourself. You're going to come across some surprises. You're going to be a better scientist, and either way, you're going to be better informed on these topics.
Okay, Dr. Standish, thank you for a wonderful message and for sharing your insights and expertise with us today. It's been a pleasure exploring these thought-provoking questions together. So I'm truly grateful for you for your time and perspective. To everyone watching, thank you for joining us today. If you found this discussion valuable, don't forget to like, subscribe, and comment. So until next time, see you.